right, good morning, guys. We are on page 111, lesson 14, surface area of right prisms. Again, anytime you hear the right, that just means it forms a right angle with the base. It's not leaning or anything, it's going straight up is all that means. So surface area would be the area of every side, every face, okay, every outside piece. So the first one says, your teacher will show you a prism. Okay, I can show you any prism you want. This would be a six-sided figure, so a hexagonal pyramid. Now hopefully you can tell that that shouldn't be sitting that way, because if I would slice it, I wouldn't get a hexagon, or I wouldn't get the whatever the base is here. So to be correct, it would sit on this end, and then every slice I would take out of it would look like this when I would cut it horizontally. They would all look the same. So what are some things that you could measure about the object? Number one, well, you could measure the area of the base. You could measure the height of the object. We could measure the each edge. We could measure the volume. That means how much liquid or things could fit in here. I could measure the surface area. We're going to get into that today. That would be the area of every side. So it would be the area of the hexagon, top and bottom, and then the area of every side. In that case, I would have rectangles, and I would have 6 of them. So to get the surface area of this, we would have to get the area of the 2 hexagons, add them together, and the area of 6 rectangles, and then add it all together to get the total surface area. What units could you use to measure these? This is pretty small. You could do inches, I suppose. Centimeters or millimeters would probably be better. Volume, you could do cubic centimeters, cubic millimeters, cubic inches. Again, that'd probably be pretty small because it's not a very big object, as you can tell. Area, again, we could probably do square centimeters, square millimeters, square inches would work as well. But again, that would be pretty small. Okay, so that should answer number 1 there for you. Question number 2, appropriately titled "So Many Faces," says here's a picture of a different prism. I did not make this one up. And it says 3 students are trying to calculate the total surface area. It says Noah says it's going to be a lot of work. We have to find the area of 14 different faces. So he's saying there's 14 different sides. So if you look at each side, outside edge would be 1, 2, 3, and there's 4 edges on that plus sign type shape. So that's 4 times 3 is 12, and the top and the bottom would make 14. So Noah says we could figure out the area of all of them independently and add them up. Elena says it's not too bad because these 12 rectangles are the same. So if we find the area of one of them, we take it times 12 and then add the area of the bases. And Andre says, wait, I can see another way. Imagine unfolding the prism into a net. Okay, so basically cutting it apart and laying it flat is what a net is. We can use 1 large rectangle instead of 12 smaller ones. Okay, do you agree with either of them? Any of them? Actually, all of them would work with no issues. They would all give you the correct answer. It's a matter of which one you think would be the best suited for you. Most people prefer this method, okay, Elena's, and we will do that here in a minute. Number 2, how big is the large rectangle Andre is talking about? I'll show you a picture of that here in a minute. And it says, will Noah's method always work for finding the surface area of every prism? Okay. Noah's method will work for any prism, yes. No issues at all. How about Elena's method? Elena's method, obviously you're not always going to have 12 identical. Okay, so it's not always going to work for every figure, but if you figure out the area of every side, that one will always work also. And then Andre's, you could always cut it and figure it out. Okay, it does ask you on number 4 here, which one do you prefer? That's going to be up to you. But it doesn't ask us for the surface area here at all, but we're going to practice one. Okay, so if I'm going to look at this rectangle, It's a height of 11. Each side here is 2. So 11 times 2 is 22. And then I have how many rectangles on the outside. We already answered that. I have 3 on each side, and I have 4 sides of the plus sign. So that's a total of 12. So 22 times 12, again, feel free to use a calculator, is 264. Now the other thing I got to figure out is my plus sign. That's my top and bottom, my bases. Again, every side is 2. You can label as many as you want. What is the area of the top and bottom? Well, again, we can just split that up very nicely. Each little square is 2 by 2, so 4. So 4 times 5 is 20. So each base is 20, and how many bases do I have? Well, I have one on top and the bottom. So 20 plus 20 is 40. So my total surface area would be 304. It is in inches, and it is area, so I'm going to square it. Okay, now just so you have an idea what that shape would look like if you would actually cut it apart and lay it flat, again, we called it a net. Okay, here's what it would look like. So that's where you said you can get one large rectangle, and then the top and the bottom. So that is always a possibility. Some people have trouble seeing the nets, and I think it's just easier to look at the different sides. All right, now we're on question 3, page 113. This is between you and your partner. Obviously, it's just you. Can you add up the area of all the faces or use the perimeter of the base method? I think it's going to be easiest to add up every side, just like we did on the other one. Now they're not all identical, so we got to pick it apart. Okay, so don't forget kind of every side here. There are some kind of hidden pictures, you know, top, bottom, back, left, right. Don't forget any of the sides. So make a little note. I'm going to do left side first. I'm just going to put a little L. That looks to be a rectangle that is 8 by 5. So the left side, 8 times 5 is 40. Okay, now how about the top piece? Well, the top piece is 3 by, now what's this? It doesn't tell me. Well, it should be the same as that. 3 by 8 is 24. That means this is 8 as well. This side is 5 by 8 again. So I'll label top 24. I'll say this is the, I don't know, top right is 40. And the way right side, right back here. Again, all those sides were 8 all the way around. So that's 2 by 8, 16. So now I got left, top, top right, right. So I need the bottom yet. Bottom is 7 by 8, 56. And now I have these two bases, the front and the back. And again, I call it bases because that is where it would sit. Normally, to be a prism, this side would be flipped on that end. So this is 7, this is 3, the height is 5, this is 2. So just like we talked about the other day, I'm going to act like this piece is there. So 7 times 5, the whole rectangle would be 35, but now I got to figure out the area of that piece that's missing. Okay, so I got to figure out the area of that triangle. Okay, well this is 2. The whole height is 5. That means the height of my triangle that's missing is 3. The whole side is 7. This is 3, so that means that side would be 4. 3 plus 4 is 7. So now what's the area of that triangle? Base times height, 4 times 3, divided by 2 is 6. So the area of this piece minus that little triangle is 29. And how many of those pieces do I have? Well, I have a front and back. Front and back is 29 times 2, which is 58. Now I'm going to add up all those numbers together. If you have a calculator, please feel free to double check these numbers. I get 224 square centimeters. Okay, so I just figured out the area of every side, and then I added them all together. Okay, again, just area of every side when you figure out surface area. Last question we're going to talk about, I just want to mention this, are you ready for more here? Because everything, again, this would be like a right shape, makes a nice 90-degree angle. This is called an oblique shape. It is not a nice right angle. That's, it's diagonal there. So as in a deck of cards, each card measures 6 by 9 centimeters. When the deck is 2 centimeters tall, find the volume. Well, remember formula for volume. Different than area. Volume, remember, is area of the base times the height. So the base is 6 by 9. 6 times 9 is 54. Times the height of 2. Volume, remember, is labeled cubic centimeters in this case. Question 2. When the cards are fanned out, like this one, the distance from the rightmost point to the bottom card to the rightmost point is now 7 centimeters. So it's saying this is 7 centimeters instead of 2. Does that change the volume if you were to fill this up? Okay, well, the height doesn't change. Okay, if you picture a person standing here, you are always going to measure your height this way. Okay, if you measure at a diagonal, that is not your height. Okay, that is not your height. Your perpendicular distance is your height, and that's not going to change. The height of the cards are not going to change. So the formula for the area, or the volume, excuse me, is going to be the same. Area of the base, it's still 6 by 9 on the bottom, 54. The height is still 2. This deck of cards and this deck of cards are going to have the same height, even though you fan them out. That has nothing to do with it. So your volume is the exact same thing. All right, that concludes today. Notice you have some surface area here. Figure out the area of every single side, not volume, surface area. So your homework, page 115 to 117, guys, 5 questions. All right, hopefully you guys are taking care of yourselves and continue to stay safe and healthy. We will talk to you soon.